if L is regular, then there exists DFA for it, right? There is DFA for it. So let's say that M is a DFA such that M is a DFA such that language of M is equal to L. Language of L is equal to L. Language of M is equal to L. It means that M is a finite representation of language. Now, if there is L, then L complement. If there is L, for every L, what is L complement? We know that L complement is equal to summation star minus L. L complement will have all the strings. Will have all the strings that are not in L. All the strings that are not in L. So L complement has all the strings that are not in. Okay. Let's say that now this M could be something like this. You are going to have an initial state UI, and there you are going to have set of states. Okay. You are going to have set of states, that is Q. Right, so this is the set of states, QI plus 1, and so on. These are the set of states. Now, there is going to be one final state also, and you are going to have the transitions between the states. Each states of here partitions being some sigma star, the set of all strings. If this is sigma star, which is equal to set of all possible strings, set of all possible strings. The sigma star is the set of all possible strings. Then what happens with this? And so on. If this is a set of all possible, if this is a set of all possible strings, now you know that each state in DFA. Now you know that the states of DFA kind of partition the set of all possible strings such that each set represents one partition, right? Each set, for example, all these strings in this partition will come under a state, let's say QI. Similarly, all these strings will come under a state, let's say QI plus 1. Any string in this partition would always end up at QI. Similarly, any string in this partition will always end up at QI plus 2. Similarly, any string in this partition will always end up at QI plus 2. Any string in this partition will always end up at QI plus 3. Any string of this will end up at QI plus 4. Similarly, QI plus 5, and so on, so on. And so on, so on. So each state is corresponding to every partition. There is going to be one state. Okay, corresponding to every partition, there is one state. So for QI, you have got a set of strings that will always end up. If you set any string from this partition, it will always end up at QI. Similarly, there is going to be one, let's say QI plus 1. Then there is going to be a set of strings that always end up at QI plus 1. Right? Very good. QF represents many strings, all those strings that when you give it to the DFA, when you feed it to the DFA, it will end up at QF. Okay, QF represents all those strings that when you feed it to the DFA, it will end up at QF, always, right? Okay. Now, because QF is final state, then language of M is equal to this. Language of M is equal to this. Right? Let's say I create a DFA M dash, which is M dash, such that in DFA M, I make the final state as non-final. I make the final state as non-final and non-final as final. Non-final as final. Okay. So if this is your M, let's create M dash. What M dash would be? Would be like. Let's create M dash. Let's create M dash. So M dash would be like this. You have Qi. Because Qi was not final here, I will make Qi as final. Similarly, there will be many transitions between the two states. Qi plus 1, there will be transitions between these are the transitions between same transitions between the states as this is Qf. Qf and so on so on. So what I am going to do with M dash is I will make Qf as non-final and I will make others as final. Qf as non-final and others as final. Done. Qf as non-final and others as final. Now, what is the language of M dash then? If you are making final as non-final, means final state of M as non-final, and the non-final states of M as final, then what is the language of M dash? What is the language of M dash? So any string, if you see in M dash, any string that will end up at QF will not be accepted. Any string that will end up at QF will not be accepted, and all those strings that does not end up at QF will be accepted. So any string that will end up in here in Qi plus 1 will be accepted. Any string that will end up at Qi will be accepted. So any string that will, so what does this mean? So you are not accepting L of M. You are not accepting L. So whatever, because QF was L of M. QF was what? If you look at here, QF was L of M. So QF is L of M. And apart from L of M, you are accepting every other string, which is equal to Computation star minus L. So that's it. So we get, so what you get? You get this. You get this. If L is a regular language, and M is a DFA, if L is a regular language and M is a DFA, such that L of M is equal to L, then L dash is also a regular language. And DFA for L dash can be obtained, and DFA for L dash can be obtained from M by making the final state of M as non-final and non-final state of M as final, by making final state of M as non-final and non-final state of M as final. Okay, very good. So it means that regular languages, because if L is regular and you can give a DFA for L dash, it means what? It means that regular languages are closed under complementation. Regular languages are closed under complementation. Let me take one example of a DFA. Like for example, now this knowledge about the language and its complement and how the DFA for complement can be obtained if the DFA for L is wrong, actually helps you to construct DFA when it is tough to give direct DFA. I mean, for example, 1 minute. So let's take an example. Okay, let's take one example of let's say L